You know, we've all been pretty blown away by AI that can write poems and crank out code. But I've been hearing so much about this next step, AI agents, and I really wanted to get my head around what they're all about. So I dug into this incredible survey paper, The Rise and Potential of Large Language Model-Based Agents. And it really boils down to one fascinating question. What if AI could do more than just talk? What if it could actually act?
And that, right there, is the heart of it. We're talking about a huge shift, moving beyond AI as just a passive tool that waits for our commands. We are literally stepping into an era where AI is an active participant in our world. This is that leap, from a language model to what these researchers are calling an AI agent.
So what exactly is an AI agent? Well, the definition is actually pretty simple, but it's also incredibly powerful. Think of it as an AI that can sense what's going on around it, make a decision based on that input, and then, and this is the key part, take an action to affect its environment. So it's not just about processing data, it's about perceiving the world, thinking, and then doing something about it.
Okay, so how does an AI actually make that jump from talking to acting? To really get it, we kind of have to pop the hood and see how it's built. The researchers behind this paper laid out a really simple but honestly elegant framework for an agent's anatomy. Now, what's so cool about this slide is that it gives us a blueprint for an AI agent. And if you look closely at this diagram, you'll see it's designed a lot like, well, a person. You've got a brain for thinking, senses to see and hear the world, and hands to actually do stuff. The AI agent is built in pretty much the same way, with the three core parts you see here: the brain, perception, and action. So first up, you've got the brain. This is the engine of the whole operation, and it's powered by a large language model, an LLM. Yep, these are the same models behind the chatbots we're all using. And they're perfect for this because they have so much knowledge and this wild ability to reason and plan. The brain is the core controller. It does all the heavy cognitive lifting. It remembers things, it pulls up facts, and most importantly, it figures out what to do next. But, a brain isn't much good without any information from the outside world. That's where the perception module comes in. These are the agent's senses, and they're not just limited to text. This module can look at images, listen to audio, and read words, giving the agent this really rich, multi-sensory picture of whatever environment it's in.
And finally, once the brain has taken everything in and made a decision, the agent has to do something. That's the job of the action module. Think of it as the agent's hands. This is how it actually carries out the brain's plans and influences the world. And as you're about to see, its abilities go way, way beyond just typing out a sentence.
And this slide just lays out brilliantly how versatile those actions can be. I mean, of course, an agent can spit out text, right? Just like a chatbot. But then, moving down the list, it gets way more interesting. It can use tools, so it can call on other software, run a piece of code, or search a database. And even crazier, it can take embodied actions, like controlling a robot arm or flying a drone. It can actually interact with the physical world. All right, so we've got the blueprint for a single agent. Now let's look at how they're actually being used out there in the wild. And what's really fascinating here is that they don't always work alone. In fact, some of the most impressive things they do happen when they work as a team. So you can have a single agent acting as a super powerful personal assistant, right? Knocking out a specific task for you. But the real game changer here is the multi-agent system. This is where you get a whole team of agents who can work together or even compete with each other to solve these incredibly complex problems that would just be impossible for one agent to handle on its own. So how does this whole teamwork thing actually play out? Let's use the example on the slide, building a piece of software. First, the system breaks the whole project down into smaller chunks. Then, it assigns specialized roles to different agents. You get a coder agent, a tester agent, a project manager agent, the whole crew. Then these agents actually talk to each other, debating ideas, sharing updates, pretty much just like a human team would. And finally, they pull all their individual work together into the final product. It's like a digital assembly line for intelligence. Okay, so we've gone from a single agent to teams of agents. The next logical step is, well, it's even more ambitious. What if you didn't just have a team, but an entire society of agents, all interacting with each other and with us? Now, this is where things start to feel like science fiction.
But this isn't some brand new idea. Way back in 1986, the AI pioneer Marvin Minsky had this theory that real intelligence isn't one single big thing. Instead, it emerges from all the interactions between lots of simpler, specialized agents. What's so wild is that now, today, we're finally at a point where we can actually start to build this stuff and test that theory out.
And this is a glimpse of what that might actually look like. I mean, just imagine a world where AI agents and people just coexist and collaborate seamlessly. You've got agents in the kitchen planning your meals, ordering your groceries. You've got agents performing as a band at a concert. And outside, you've got agents working right alongside humans on massive construction projects. It's this incredibly dynamic, interactive world where artificial and human intelligence are working hand in hand.
Now, this vision is obviously incredibly exciting, but like any truly powerful technology, it is absolutely a double-edged sword. We have to be really clear-eyed about weighing the immense potential against some very, very significant risks.
The promise? It's a world where agents handle all the mundane, repetitive stuff, freeing us up, our human minds, for creativity, for innovation, for scientific discovery. Just imagine agents helping us cure diseases, develop clean energy, or explore the cosmos. They could become these amazing partners that help us solve some of humanity's biggest, most stubborn challenges.
But the peril is just as real. We're facing the specter of malicious use, agents being weaponized to spread misinformation or launch cyber attacks. We have to think seriously about the potential for massive job displacement, and also the risk of just weird, unexpected, harmful things emerging from these incredibly complex systems.
So the crucial takeaway here is that as we build this new world, we absolutely have to build the safeguards at the same time. The researchers have flagged these critical challenges that we have to get right, making sure these agents are trustworthy and fair, protecting our data, stopping them from being used for manipulation, and maybe the most important one of all, designing these systems so that humans always remain in control.
Which leaves us with this final, massive question. Because this technology isn't sci-fi anymore. As we actually start to build these societies of mind, what kind of world are we creating? Are we opening a door to some kind of utopia of human-AI collaboration? Or are we opening a Pandora's box of consequences we can't even predict? The answer, it seems, is really going to depend on the choices all of us make, starting right now. Thanks for joining me on this deep dive.